Happy snowy Monday, everybody. That's right. We were 80 degrees this weekend, and Monday night we're getting snow. Of course. Who designed this game? I got to help them with their weather module for this thing. But we bring you warmth in the form of the baked potato jam. Alex has the baked potatoes. And Godot Ray marching. Alex also has that. And he is going to be sharing it with you. You can't see his face. You can see my face right now. I'm going to hide my face in a minute. I'm going to make a few announcements. Then we'll get back into the fun of Ray marching. A lot of you did enjoy this last video that he did. Appreciate all the views on YouTube, all the feedback on the Discord. So look forward to more of this. A couple announcements. Let's see. Eric Lorenz is doing his game jam around making games about protest. That's going to be April 4th. April 17th is the jam, but he's doing a kickoff on April 5th at the supermarket. That's not a grocery store. It's an art space in Cabbagetown. So 6 to 9 p.m. at the supermarket in Cabbagetown. The kickoff for Avant Beatles protest games game jam. And Eric's been doing the great Avant Beatle game art pop-ups. So hopefully we can get one of your game jam projects in there. If you're interested in seeing how to run a game jam, go there, help out with Eric. I'm sure you can always use helpers. So that's April 5th. April 14th, we have the Best in Georgia Award. The Gwinnett Tech, going to be 6 to 9 p.m. Check out all the Best in Georgia candidates. And we will get to play them, and then we will name the best one, the one who will win all the prizes. In May, we have both MomoCon. Well, we've got Games Week Georgia, then MomoCon, then DreamHack Atlanta. Oh, sorry, I got that backwards. Games Week Georgia, DreamHack Atlanta, then MomoCon. So it'll be a busy month. I don't think we're going to have a separate GGDA meeting. That's why I've been doing stuff like the ASFE last weekend that I hope you all enjoyed. But if you want your game in, let us know. DreamHack has the registration available right now. Indie Cluster is doing the registration for MomoCon. And we're looking forward to a really great May. And hopefully coming back up for air in June. If there are other things you want to share in the chat, feel free to. If you have questions or comments, go ahead and share them in the chat. As I noted in the chat, we do recommend having Godot open to follow along. And with that, Alex, let's go ahead and butter this potato. Take it away.
Thank you, Andrew. I wish I could bottle up all of the energy you have when you introduce me. I feel like it would be far more effective than various antidepressants I've tried. So thank you for that. Yeah, I'm picking up from last week or 2 weeks ago about Ray marching. And the theme of these videos really is that I kind of don't know exactly what I'm doing. And I'm just kind of failing my way through it. And so that's the concept, is to just fail your way through it too, along with me. Or maybe you know a lot more and this stuff is a lot of it's easy. But I kind of want to just leave space for people to leave their perfectionism behind by streaming all of my errors live to the whole wide world. So to kind of pick up where we left off last time, you'll need to download the project state that I ended with. And if you go to my GitHub, which I just learned how to use, and go to github.com/bustedclutch, you can click into this Godot Ray marching tutorials link. And if you click on code, you can download the entire file by clicking code and then clicking download zip. And then that'll get you all 3 of these chapters. And each of these folders is a Godot project. So you'll find an actual Godot project file in each one. So you should be able to just pop it into Godot and it'll launch ready to go. And then if you're just looking for a piece of code in each one, like the movement script that we'll be using today, you can click into public and then you can see the various parts, including character body 3d.gd. That's a GD script file. So this is the movement thing we'll be touching on later. Last week, I talked a lot about the physics of ray marching and how it kind of functions under the hood and how to write a very basic shader. I'll pop that open now. And I went ahead and added a bunch of comments to the shader file so that if you missed last week or just you don't have, remember it all, or you like text better, I tried to explain each section of the code as well as I could. And of course, there's lots of more videos online about the theories of ray marching. I'm gonna pivot over to Godot now, so give me just a moment to switch streams. And Andrew, am I showing Godot now? Is this all? Do we see Godot things happening? Lovely. So this is the end state of chapter 3, and we'll be starting with the end state of chapter 1, but I just wanted to give everybody a sense of what the destination is. So I'm going to play this scene. And I've got a ray marched shader, a little simple character who can move around, and he can apply forces to these marbles that are on this platform and jump and do some basic movement. So let me go ahead and get out of there. I'll quit to the project list. And here is where you would import. Oh, I closed stream. Let me. Thanks, Andrew. Let me. It's going to do this again, but that's okay. Is it showing now? So this section is where you would import a project. And in this case, you could just go ahead and import chapter 1 end as a file. And then that would let you start where we're all starting together. But in my case, I'm going to duplicate it. So we'll duplicate chapter 1, live stream. It's probably going to close out the window when I do this. So, yeah. All right, I'll get Godot back up. I think thanks. So this is where I left off last time. I had quad with a simple camera, and the quad is showing a ray marched shader, and behind it is a ball. We can run this scene, and it's not lit at all, so the ball is just a gray mass. But it gives us a concept of kind of like where we're headed. So today, let me get my notes back out. I wanted to get a game like on the board as fast as possible because I know, when you're working, it can be tempting to stay in the concept phase forever, rather than just getting a game loop on the ground as quick as you can. So I'm going to try to get a game, like just a simple thing happening as fast as I possibly can today. So I'll start a new scene. Up at the top left, scene, new scene, or Control N. And I'm going to close this out because we don't need it for now. And it's going to be a 3D scene, so I'll start with a 3D scene as the root node. And we'll call it Game World. And as you saw before, I had a platform, I had these marbles, I had a character that moved around, and I had a camera. So we can start getting those basic shapes into the world now. So the floor, I'll start with that. So I can right click it and do add child node. And there's 3 physics shapes that I'll use. The first is the static body 3D. So this is what floors tend to be. It can't be moved, tends not to, uh, unless you script it to do that. I'll create that static body 3D. And if you like renaming things, you can rename it floor. I don't think I did in my project file. It gives you a warning right here, a little yellow flag that says it has no collision shape. But it's really missing 2 things for our purposes. It's missing both a collision shape and something to help us see it. And those are 2 separate nodes. So the first thing I'll add is a collision shape. So I'll add a child node to that. And then we get another warning, right? Because the collision shape, we have to pick a shape. And that is over in the inspector panel on the right, up top. And since our floor is just going to be one big old box shape is easy to choose. And then I'm going to add a visualization, because if we were to just see this in the game, this box would be invisible to us. So we need to be able to see something. So I'll add a child node. And Mesh Instance 3D will let us pull in some boring, simple meshes. So we're going to get that in there. And this one does not give you a yellow flag. But maybe it should, because if you don't have anything in there, then there's nothing in there. So you'll still do something similar as you did with the collision shape, and you'll select box mesh. And these just happen to line up. They won't in a minute, so I'll show you how that pans out. And I'm going to go over to transform and the node 3D. And I can scale this up. First, I'm going to unlink these, because if I was to do 15 here, I would end up with a gigantic box, which is, not what I want. I only want to adjust it for 2 of my dimensions. So I can bring the Y dimension back down to 1. And here we've got something that looks like a floor. But that poses a problem right off the bat, because our collision shape is still this tiny little box in comparison. But it has these handles, so we can fix the handles, or again, we could, move it around and type in new numbers here. But just for educational purposes, I'll move the handles and get you there. And get you there. That only takes care of 1 dimension. So let me get the other. And that's our floor. And we'll do a similar thing to get 3 marbles out on the ground. I was looking at very simple games that I thought might make sense for a ray marching shader, and I thought, well, maybe a child's marble game would make sense, because, marbles are kind of inherently visually interesting and have a lot of, weird glassy translucent features that I thought could make sense for a ray marcher eventually. So that's the destination, is marbles. So that will not be a static body 3D, because we need to be moving around. So we'll add a different kind of child node. In this case, a rigid body 3D. And we get that same warning. It expects a collision shape. So we'll do just as we did before and add a collision shape 3D as a child. And then this time we'll select a sphere. And right off the bat, I notice my floor is taking up, it's hogging the show. So I'm going to go ahead and move that floor out of the way. I'm selecting the floor, grabbing that green triangle and moving it down a smidge. And it's still quite difficult to see the marble, so I will just toggle the visibility of the floor off for now. And then just as we had with the floor, we'll need to make this visible. So I'll add a child node here. And mesh instance 3D. The mesh of, I know there's a sphere in here, there we go. And it looks like these line up perfectly. So I'll select the collision shape and you can see the handle lines right up when it's default state. I'm going to leave that alone because our Raymarched shader already had marbles in which the radius was 0.5 meters, and this just so happens to be a 0.5 meter radius sphere, so I'm going to leave that as is. And I'll go ahead and rename this marble 1. And then I can bring back floor now that we can see the marble. And then what's in front of the player, generally speaking, at least in terms of our sense of where the camera is in space, is down the negative Z direction. And so you can see the positive directions both on these handles and in the gizmo. So I'm going to go ahead and move this marble over yonder to be in front of where the player will be. And I want to have something interesting happening right off the bat, so I'll Control D to duplicate this marble. And that will create another marble that's already numbered what I want it to be. It goes from marble 1 to marble 2, which is convenient. And I can just drag a handle in the Y and X directions. And I'm setting these marbles up on a collision course because I want to see if gravity works. And then I'll Control D on that marble. And that is our third marble. So move that a little bit around. So now when they fall, they'll bounce a bit. And then this would not work if I was to just hit run current scene. I'll do it anyway, just to, we'll go ahead and save our game world scene. Yeah, we just see gray, right? Because it's a 3D scene. If you're used to working in 2D, I think you don't actually need to add the camera. I think it just already starts showing up. But in 3D, you always have to have a camera in order to see anything. It won't know what to do otherwise. So game world, for now, I'll add the camera as a child of the world. But we'll change that later. And when the camera is selected, it shows a view in the inspector panel. But we'll add another view of that later. And if I run it again, no lighting, very, unpleasant to look at. Because right now the editor is just giving us a default world environment and a default sunlight. And since, again, we are just rushing this process, I can click that triple dot to the right of the sun and the environment buttons and click add sun to scene, add environment to scene, and that will just duplicate what I'm seeing in the editor. I can run it again, and now we see things happening. And We are still missing our character. So I'll add that as a child of Game World. And for now, I'm going to do character body 3D, and I wouldn't get too attached to this because I might change this later to rigid body 3D. Character body 3D, you have to code all of the physics for that character. It doesn't come with much in the way of physics. Whereas we saw with the rigid body 3D, it already had gravity, it already had real world physics applied. Is not the case with the character. So that warning in mind, I'll go ahead and create that character body 3D. And same problem as before, right? Nothing to visualize the character, and then no collision shape. And we're going to be working with this node a bit, so just for my own sanity, I'm going to drag it up to the top, if I can. There we go. And for fun, I just downloaded the GD Quest robot because it's open source and it works well and it's cute. So we're going to put that into our scene, and I'm going to shift streaming gears momentarily just to show where that is in the file. So 1 second. And character is in both chapter 2 and chapter 3. So I'll click in the chapter 2. And actually, I don't know if you are able to download individual folders while you're in GitHub. I'm relatively new to GitHub. But if you downloaded the whole repo, then under licensed assets, you'll see this GDQuest GoBot folder. So what I'm going to do, and it won't be streamed because I don't want to stream my entire file system, I'm going to take this GDQuest folder and I'm going to drag it into the project folder for my game. So for the current project I'm working on. So now would be a good time to kind of throw questions into the chat, because this will take me probably 2 minutes to move those files around. And probably the viewers too. Oh, fun. All right. Well, I hope. Let's see. Emerging live stream. I don't know if talking out loud while you work is a good default trait to have while you're streaming or a bad one. But it's what I'm doing. So let's see. So now let me change my stream over to Godot again. And you might have seen that it did a little importing assets, dialogue, where it automatically imported things. And you can now see in the file system, which is the bottom left of Godot's default window, you can see I've got a folder for licensed assets and then GDQuest _GoBot. And I decided to I don't know what the norm is for naming folders. For me personally, I liked the idea of just having other people's work on a separate folder so that, I know to credit them when I'm working, and, kind of keep that in my brain. But, whatever system works for you. So this GDQuest GoBot includes two things that we're going to be using. One is the scene. So we can actually go ahead and open GoBot scene file by double clicking it. And then we see GoBot, and he's cute. That's why I'm using him. And he comes with a script. And so if you're just dragging in assets off the internet, you can pop open the script and oftentimes get a sense of how you access the assets. Sorry, because in this case, he's got a state machine, and the only thing that you have to do to trigger these animation states is just to use this like run function, jump function, um, fall function. That's all you have to write. And then the magic kind of happens behind the scenes with the rest of the scripting. In this case, I don't think it's a super complicated script, but one of the things that I do notice is happening is he's got this tween situation where I'm pretty confident that keeps the animations from cycling between one and the other too suddenly. It kind of has some give, like some interpolation, to make the animation look right. So back to our game world. And I've got my character body 3D, and I want to go ahead and add that visualization of GoBot. And I can right click character body 3D, and I can do instantiate child scene. And it gives me this window. Not a whole lot of options here. In this case, we're going to do this TSCN file. It can be tempting to click on that GLB file because you see GoBot, right? That kind of is a red herring. The scene file is what includes everything about him beyond just the 3D elements in the animation. And you want that scene file because that's what lets you access the script easily. So I'm going to click that in there. And then he also needs a collision shape to get rid of that yellow warning. So we can go ahead and add a collision shape as a child node. And we need that collision shape to have a shape. And very commonly in 3D, a capsule tends to be what you use. And as you can see, obviously here, the capsule is not lining up with the character. So we need to move the handles around to there and there. And in general, I think the rule with collision shapes is you make them more forgiving for the player, whatever the system is. Because something that you can't see and causes problems enrages the player more than something that kind of gives you a little bit of buffer. So he's got a collision shape. The first kind of major problem he has, from my perspective, is that he's looking towards the positive z-axis. And we know up till now, Ray Marching shader and kind of the rest of the world, we've been working with a negative z-axis as forward. So I'm going to go ahead and spin him around 180 degrees with the Y. With this, I'll first do it with this handle. Get him mostly where I want him. And then I can open the transform and set it to exactly -180. And then we can hit play just to kind of give a sense of where are we now. And we see what's, I think, the bottom of his legs. And that will not do. So we want to have the camera up above and over him and following him around. And I'm going to do something really, really simple. You can go on YouTube and see more complicated camera arrangements, and GD Quest actually has some great videos on doing that. So I'm just going to do something easy, and I'm going to add a child node. It'll be a 3D, just a simple node 3D. And I'm going to rename this camera pivot. And then I'll make the camera 3D a child of camera pivot. And why we do this will make sense in a moment. So I'll initially back up that camera behind GoBot. And I don't like working with this inspector view of the camera, so I tend to click this view menu item up above the 3D viewport, and then I can change it to 2 viewports Alt, and that splits my viewport into 2. And then I can click this preview button and get a camera preview. And if you can't see that, I think you can find it under cinematic preview. Will get you the same place, but they've kind of made it accessible by making it a little checkbox. So right now the camera is behind him, and then that camera pivot node, I can rotate upward. So I've got the camera pivot selected, and I can move that to be above and behind him. And that's still a bit too close. And if I were to move the camera now, I would start moving it in global space, which may or may not be what I want. But so you know where it is, I can go to local space, and then I'm in the local space for the camera. And then I can back that out a bit more, depending on what my preferences are. And because the camera is a child of our GoBot character, it will just move wherever the character goes. So we can go ahead and hit run current scene. And here we are. We've got a floating in space GoBot. Because he's a character, body 3D, he needs a script to move. So that's the problem we're going to solve next. And if you downloaded the entire repo, you can find the script in that zip folder. I'm just going to switch back to my browser and show you where you can just copy and paste that code now. So let me switch my screen share. Let's see. So I'm in Ray Marching Chapter 2 end, and I think it's the same script in Chapter 3, but I know in Chapter 2 this is kind of our current destination. You'd find it in public, and then we know our scripts have this .gd ending. So character body 3D has this script. You can see it extends character body 3D, so we know that it works for that purpose. So I'm just gonna copy and paste this whole situation. And we could have our first disaster in a moment because I haven't actually copied and pasted straight off GitHub, so we'll find out if this actually works live. Uh, you say that, but character body 3D. So I'll right-click character body 3D and then click attach script. And then it gives me a prompt of where I want to save the script and how I want to name it. And I did use a template. This is based off the just generic template that Godot ships with. If you're following a tutorial, they'll almost say to start blank so that you can learn how the individual parts work. But I'll start with a template just so you can see what the template looks like before I get rid of it. So this is a very basic movement template that you can start out with that gives you jump and it lets you move forward, left, and right with a speed and a jump velocity. We're going to get all of that though and replace it. And we'll see if I caused any problems. And then the first thing I'm going to do is I'm just going to go back to my scene and hit run and see what happens. And I crashed. That is because I haven't yet created. Let me put my mic away while I do that. He still needs a wand. And if you're doing tutorials, you'll kind of find these kind of cute euphemisms for a marker in space that indicates, where a projectile comes from. I mean, obviously, that's for the much more common first-person shooters. But when you hear tutorials refer to like wands and kind of child-safe stuff, like that's what they're getting at. So those tutorials, are very useful, even if you're doing something for, just for adults. So I'll return to my 3D scene and I'll add GoBot's wand. And I'm going to check from the script because I don't remember. Yeah, the wand is just a child of the character body 3D. And let me see if I can find another reference. That dollar sign, I'll just type one in. Say, typed declare a variable. Test variable equals. Once I hit that dollar sign, I can start seeing all of the direct children of the node, as well as the sub-children of those nodes, respectively. So I could keep going, down the line. That's one way of referencing nodes on the tree. And then the other way is to right-click something. Say I wanted to reference, I don't know, anything. Just access this unique name where you use a percentage marker instead. And that lets you move the node around and, have your stuff not break if you change the node locations. But I'm going to stick with what I've got now. So back to the 3D scene. I want that wand in place. So the child node. And this will be a marker 3D. Its whole job is to, mark a position. And that's pretty straightforward. So create that. And then crucially, I need to name it wand for the script to work. And then let's take a look at where it is. The marker 3Ds are really hard to see, honestly. So I'll drag it out a bit. And you're not crazy if you're like, I can't see the marker 3D. I mean, zooming in, you can see this little box inside of a box. Zooming out, you can barely see a cross in space, which might not show up on my stream at all. But they are challenging for that reason. So here is where you would define, say you were playing a first-person shooter and you wanted to do just any character that launched projectiles. This marker 3D would be used for determining where the rays are sent out by the engine to determine intersections and so forth. For a true first-person shooter, that ray is going to, come from your actual camera. But for here, since we're currently third-personing it, we're just choosing something in the middle of the character for now. And let's give it another go and see if I crash. I didn't crash. That's amazing. And none of my buttons currently work. So, that's still a step above where I was before. So we need to map the buttons. So I'm going to hit escape. Close that out. And then if you're wondering, where do I map buttons? Here's where you map buttons. You go project settings, input map. It took me way too long to figure out that the built-ins are just accessible through this toggle. So this is where your built-in actions live. So if you see a lot of references to UI underscore something something, that's where those are. So we need to map left, right, up, and down, which is up top. So you see left, I'm going to double click that. It's listening for input. And then I'll go ahead and give it a key. Same for right. Give that a key. And then up, give that a key. And then down, I'll give that a key as well. So this is where you see that I'm a weirdo. I don't actually use WASD to move because I find that confusing. I use ESDF because then the glyphs that come up on screen are visible, are understandable to me because I'm a touch typist. So if you are downloading and importing the whole project and you're like, why are these keys screwed up? You're just inheriting my WASD settings, which you can change here. And I think it already has the spacebar mapped to jump, but we'll find out. Run that scene again, and I'm moving. And that spacebar is already mapped, so I'm jumping. And I already have some limited interactions I can do with the rigid body 3D. It does collide a bit. And then I don't have a kill plane set up, so once he's falling off the platform, he's doomed to the nothingness forever, like the ending of his Dark Materials. But not us, because we can hit the escape key and escape the unending void of nightmares. So we'll hit escape, hit X. Off we go. And then I wanted to do one last kind of feature. So we can pop open the script and see what I have this wand doing. This wand is responding to another input, which is the fire input. And when it fires, and I know I need to make this script bigger because this is very small. When it fires, it pulls everything in the world. That's that get world 3D. You know, what's out there, world? And then it creates a ray. Ray starts with the position of the wand that we said earlier, and then it finds the end point, which is the wand position plus the direction times the length of the ray. So then it queries whether there's an intersection. Right now it's printing for debug purposes that intersection. And then it's asking through the logic here if that's a rigid body 3D, which is our marbles, in which case, if that's true, it does this apply impulse, which is how we manipulate the physics of the objects that already have real world physics. And you have to be careful with the rigid body 3Ds, because if you were to just do transforms, like set a new position in the script, that would break everything quite quickly. You have to make your physics manipulations tie in to the existing physics functions of the Godot engine. You can completely arbitrarily reset where something is, but you need to use a different function for that. I'm blanking on the name of that function. It's something like incorporate. Well, maybe it'll come to me later. I don't know if we have anything else in here that is interesting. I don't know. Yeah, this would all be covered. The rest of it would all be covered by a movement tutorial from GD Quest or others. So I'll leave that alone. To my game. And right now, I didn't map a key to pulling and pushing the marbles. So I'll go back to my project settings and my input map. And then here's where I can add new actions. So right now I have built-in actions, and a lot of people never touch the built-in actions if they're not using templates. So, you know, a lot of the time this is the only kind of interface people are using. So I'll add a new action called fire. And then I'll add a new action called pull. And then I need to give these keys. So I'm going to just make that simple with a left mouse button. And then I'll make the pull the right mouse button. And then here we are, pulling and pushing marbles. Maybe. And I thought, I was like, maybe this would be a game, would be the marbles just go everywhere and you have to keep them on the platform. Or, you know, turn it into a pinball machine. Lots of different kind of thoughts I've been having about where to take this tutorial. So that's working. Hopefully it's working for you at home if you're following along. And now I need to check my notes. And I guess if now would be a good time to kind of type in questions if people have questions while I check my own notes for what I need to do next.
I have a question while you're digging that up, Alex.
Yeah,
So
yeah.
you've played around with a few other engines.
Oh, I
Uh,
haven't. I have no idea how
oh, I
Unity
thought you'd
or
played around with
Unreal
some others.
work.
So what's your thoughts on Godot so far in general?
I really like it. Um, I mean, I started learning. I mean, I'm 41 now. I don't think I started this until I was 40. The whole engine felt pretty intuitive. Um, Trees felt intuitive. It felt similar to Blender when I work in Blender, which I had more experience with. One of my favorite features, and this might seem kind of weird, is that there's no installation. You just have this like 300 or so megabyte application that runs on Linux or Windows or whatever. Um, and so when I'm editing, I like to just throw my stuff on a thumb drive. And I work on different computers too. So the ability to just like throw a project on a thumb drive and then launch it anywhere, even on a like potato laptop, um, I just find really, really, really nice. Um, for simple games, that kind of thing, I don't know if that kind of luxury appeals to you. I think it's great. Uh, I don't find the coding challenging either. I think they picked the right. It's the right trade-off. Like the nodes are all written in C++, so to the extent you use nodes, those are very fast under the hood. And then that GD script is the slow script, but if you really needed some like fast simulation happening in the background, um, there are tools to route that in the background with another language. So in case you need it, it's there. Uh, but yeah, I do need to play around with Unreal, and because that's probably the one I'm the most curious about. Because seeing like their whole shader tree situation. I will say Godot also forces you to learn a lot of the basics, which I think is cool. Because you just have to kind of create the game from nowhere. Um, but you start from zero, and even though that can be a little stressy at first, I found it gave me like confidence once I kind of got over that hurdle. Uh, but yeah, I like it, which is why I'm using it and why I'm live streaming about it. And then of course I love the fact that like you don't owe anybody any money if you publish a game. You can just be like, yeah, this is my game, and you're not subject to any like download fees or whatever. Um, but yeah, if I was to make a switch, I might try out Unreal because I do find their super realistic imagery stuff interesting. Uh, so that one is my temptation and what I'll probably try next.
That was a great review of the strings. Thank you.
Uh, Thank you for the question. My let's see if I had a note. Um, doo, 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 doo. Oh, the function that lets you just unilaterally move the position of an object that's a real world physics object is called integrate forces. So that's the function that you deploy if you just want your marble to suddenly be at some other point in space. Integrate forces is what you do. Um, and then we're at 7:54, and I think we have plenty of time to attach our Raymarched gel to this whole situation. I'm going to take 30 seconds to drink some water because I find talking for a straight hour challenging.
That's right. Other streams are brought to you by Red Bull and Monster. We're sponsored by water.
Yeah, I'm sponsored by water. Uh,
And sometimes a dry rosé.
And I've somehow lost my left side panel. So if you've lost your left side panel, here's your distraction-free mode button to bring everything back. So I'll go ahead and reopen that basic ray marching visualization. So this was the shader that existed before, and it just mapped a box to spheres. And in our game world, the idea is how do we replace these spheres with a ray marched object instead? Because, say we want to have a smoke grenade or uh, a translucent ball that has a lot of interesting refractions, then we need to get rid of this physical object that we see here now and replace it with a ray marched object. And there's multiple methods to doing this, but I've chosen what I think is just the most immediately accessible one, which is to paste a gel in front of the camera. The first thing I'm going to do is create our quad. I'll add a child node. Actually, I'm going to add a child node that's a child of the camera because it'll be a gel for the camera. If the gel is not a programming word, that is a like movie set word for like a actual physical object that you slap onto a real life physical camera that or a light more commonly that changes the color of a light. So that's why I'm using the word gel. We'll add a child node, be our mesh instance 3D. And we'll be using a quad. And then for surface material override, I can start with my the basic ray march shader I was using last time. So I can just drag this over and we'll see if it's showing up. And here it is, right in front of the camera. And you can see the camera isn't seeing it yet because the camera has a near plane and a far plane and it's on top of the camera. So we want to move it in local space. This is where that local space button matters, which again is up here. Is T is the hotkey. And I'm going to move it in front of the camera. And it's going to start blocking things. I'm not going to get into today having the circles match up exactly, but the field of view does happen to match up exactly just because the default camera has a 75-degree field of view, and that is also built into the shader as it stands now with that 1.303 number. Let's see, mesh instance 3D. So obviously this gel is, it's random objects. We need it to be the objects that are out in the world. So to do that, we need two things to happen. We first need a script from the game world that's emitting the locations of these objects. And then we also need to update our shader to accept the locations of those objects. And we're going to cheat a little bit and just copy and paste the code that I have online for both. So I'll first start out going into game world and adding a script to that. And let me shift my stream to my browser. So now we can go into chapter 3. So chapter 2 ends with the game in place. And chapter 3 ends with the remarched gel in place. So in chapter 3, public, you can see some additional scripts. I've got that game world script, which is what we're about to paste in next. And then we have the updated shader file script, which is this camera gel GD shader. So we're going to first bring in the game world script. And I'm going to beware this tool function. So I'm going to not put it in immediately. And I'll try to remember that I left it out because I want to talk about tool and what it does. So that's copied. Let me switch my stream back to Godot. And I can paste whole cloth, the whole deal. And as you can see, it's not big, and it's specifically citing a couple objects. It's picking up the camera, assuming, and this is where names matter. So if you renamed your character body 3D, you'd have to update that, or if you didn't use the camera pivot, you'd subtract that. So this has to line up to the same path that your camera 3D lives at. Same with the marbles, they all happen to be direct children of the game world node that the script is attached to. And then this is going to assume that the quad is renamed remarching gel, otherwise it will bug out, get confused. So that's getting all of the variables. On ready is what's called an annotation in Godot. That you'll use a lot. Pretty much when you're declaring variables, like tends to be like everything. At least it lives at the top, because if you try to declare these variables too early, they won't be there. They won't exist yet. So onReady delays the creation of these variables until after the whole scene tree comes into being and all of the nodes come into being. And at that point, they're ready to be declared as variables. And then we can see below process. As the comment says, this is called every single frame that you run. And it's pulling out, it's creating various shader parameters that we'll pull in later. So here's the name. It's the first parameter / argument. And then the second, this is the information it's pulling. So it's pulling the position of the camera because that matters. Our Raymarch shader won't work unless it follows what our camera sees. It also needs to follow the camera's direction. So the basis is also essential. And then for our 3 marbles, we need to know where they are. And what's missing, I mean, I wanted the bare minimum so that this didn't get overwhelming. But eventually we would want the basis for these marbles, because as the marbles like roll around, we want some sense that they're rolling, which they won't have unless their direction is able to change in the shader. And then let me go ahead and correct the name first before I forget. Raymarching gel. And then I always hit play scene every chance I get to see if something crashes, which I assume is good practice. I don't know. As we can see, the gel is following the camera around, is what I want. So we'll get rid of you. And then I'll wait on tool. I'll talk about tool in a minute. So the first thing or the next thing we'll do is get the shader code from the GitHub. So I'll switch the stream over to that. Welcome back to my browser. So chapter 3 again, public again. And we're looking for camera gel.gd shader. And we've got a very similar script as last time with a few key changes. So we can go ahead and copy the entire thing, switch back to Godot. And then rather than redo this simple ray marching gel, I'm going to create a new shader file. And I think it's under resource. This is where Alex's mind gets tested. If I can type correctly, that would also be great. We're going to believe for now that this is the correct thing to use. Yeah. And so it's already got the ray marching gel script open. So I'll Control A for everything and then paste to replace it. And so this is the ray march gel from GitHub. And then I'm going to replace the quad's current script with this gel instead. So I'll go over to the gel, the surface material override. And remember to click into this, because this is where the actual shader file lives. And I'll move it over yonder. It's replaced with this black box. So take a sip of water. The problem when you start importing variables from the Godot world is that these spheres don't have positions to report yet because the script isn't reporting anything. It's not actually running yet. So the shader doesn't have any of the essential information to pull from. So you need the script, the game world script, to actually run while you are editing the game. So we'll do that with an at tool. And save it. And it doesn't seem to take effect immediately, and I don't actually know how you get it to, do the things. We'll see if reload saved scene will do it. So I'll close that out and bring game world back. Here we are. Yeah, so closing the scene and opening it back up again will get your script running with the tool annotation. And I guess I would be remiss if I didn't tell you that tool is dangerous. Whatever you type in your script, it will start doing. So So it's very powerful in that regard. But, as a warning, Godot is not sandboxed to my knowledge. So like if you were to just change your script to like delete all of the files on your hard drive, it would just start doing that. So, you want to be careful what you use @tool with to make sure it's not actually altering anything significant. And here, bizarrely, I think I've nailed somehow the size of the objects. So let me move these around. Yeah, that was a total mistake. Usually they're out here somewhere. You can drag the gel's distance to the camera until it lines up with your ray marched objects. And I'll hit play and see what that reads like. So we've got the ray marched gel rendering these objects until the gel expires. The gel only is a square right now. And also the gel is in front of character. So because it's in front of the character, it's in front of everything, even objects that it shouldn't be. And that's something I won't be working out today because that involves depth, and that it will probably be a whole nother video. But I think it's kind of cool to get far enough that you've got these in-game physics objects being rendered directly in the shader. So I'll pop over to the shader itself just to kind of see what the script is doing with that information. So I'll close that out. I'll go to script. Actually, I can leave this open and pop open the ray marching gel here. And it has left in some of the like outdated information. So it's still left in camera position as a variable, as a hard-coded variable, even though we get rid of it. But here's where it starts pulling in variables from the script as uniforms. So uniform vec3 camera underscore POS marble POS for marble position. So that's just shorthand. And then be aware that basis is expressed as a matrix. It's so that can throw you off when you start doing math or things with it. So we'll scroll down to what else changed. There's no boxes yet, so this function exists but doesn't get used. Though the sphere function is still, of course, used. And then the get scene distance. We've revised last week's positions where we hard-coded the marble locations, and this time we've given them these variables that were expressed up above and that get pulled in from the game world script. So if you wanted to add, more shapes, this is the function where you would add more shapes. And it also is a kind of a good point to talk about, like, what are the limitations of this method? You can do lots of weird, complicated things, like you could build Booleans into your uniform so that different logic starts happening. But I guess the limit is like how manageable is that for you and your brain and your scripting abilities. But you'll see just with some like basic ray marching, people will just start out with a limited number of objects and just hiding those objects whenever they're not expressed, or using a simple Boolean to remove them from existence. It's not going to give you the ability to just randomly instantiate, dozens or thousands of things at once, because I don't know that a shader is going to, at least in Godot, is going to let you get away with that. You might have to even make your own engine to make that happen. Our get service normal is still our outdated normal function, or at least it's the slow function. As I said last time, there's a faster function. This is just the easier to understand one. Our ray origin becomes this new camera POS uniform. And then the ray direction, needs to take in the direction of the camera. So this is where the camera basis gets brought into being. And we're still using that arbitrary camera focal length rather than, but you could update this with a function that would be tied exactly to whatever focal length the camera is using at the time, if you wanted. But focal length tends, well, I don't know. Some shooters, you totally adjust your own focal length. Distance to surface. Let's see if we have anything else. I think these all largely remain unchanged. And we just brought in the direction of the camera's position, and those 3 marbles. And that kind of gets you, that gets you to here. And I did not pre-attempt this, but I'm actually quite happy with the time, elapsed time, because I didn't want this to go the full hour and a half. Because I was, making both a mini game and the shader distance. So I guess now is another question time now that we've gotten to this state, this finished state for the week.
Yeah, great stuff. And for those of you in the chat, again, go ahead and ask questions, and you will have the VOD still up on YouTube to go back to and reference. You want to go back and look over various parts of it. Appreciate those of you who've been with us this whole time. Thank you very much. Do not hesitate to ask questions about what's been shown or any aspect about this, and certainly comments about how cute GoBot is are always welcome. But Alex, definitely appreciate that in-depth look at it. A good conversation, good look at a lot of different aspects of Godot today. So very valuable insights all around. I do love the idea of using the term gel for these sort of camera things. I remember the first time I was on a film set and folks were talking about gels. And I actually expected them to slap some jelly on this camera, but that didn't happen.
Do they ever actually end up on cameras, or are they just on lights? I know that they are on lights all of the time.
Right. But it's often just various types of colored stuff.
Yeah.
Not even just a gel. So obviously a good gel will make me look a lot better. So
you look great.
Marvelous. And more folks jumping in now. If you've been watching this, ask questions. If you just jumped in, feel free to ask questions about Godot. And again, this VOD will be sitting up for you to enjoy. Yeah, I think the time went well for this. I find that I'm losing brain power after a 1 hour stream, so I'm glad you were able to keep it up this long.
I had a quick power nap beforehand. Yeah, that is the only reason I'm not brain dead, because I worked all day today.
Right.
And then I've got I think down the road I want to have I'll switch if people are interested. I kind of wanted to poll, and you can get back to me if you're just watching. I was thinking of trying to just hang out in the Discord for the evenings for a 1 week period and just force myself to sculpt a bunch of busts in Blender. So if people think that that's a good idea, participate, do shoot me a message or let Andrew know, or say something in the art chat of GGDA, and I'll pull that up just so you can see what I'm working on these days, if I can find it.
Definitely glad to have a Godot work night in any of our channels here. And Alex has always been talking about wanting to get involved with more game jams. So we'll see. Whoa! Hello!
Yeah, this is my current... let me get rid of our Andrew Loomis. if you're familiar, if you ever draw heads, then of course Andrew Miss's like very famous book about head proportions. Um, but this was me going insane with annotating in 3D head proportions. So this was something I was thinking about working on. Just having a because you just get better at art by just like forcing yourself to make a million drafts. And so I thought, oh, maybe just a week in the Discord of forcing myself to make a million drafts would be a fun thing. And that would not be me like teaching. It would just be everybody kind of streaming their own deal, whatever they were working on, as a kind of accountability of sorts.
Work alongs are great opportunities, get you to actually get stuff done and ask questions when you get stuck.
Yeah, I have a lot of Blender questions.
Yeah.
I'm glad that but that's it for me, I think. Unless you had anything else you needed, Andrew.
Nope, that's looking good. We'll put a poll up in the Discord, seeing who'd want to go ahead and do an artwork night. Sounds like a great opportunity. And yeah, the VOD will stay up, and keep referencing back to it and check into the Discord, and we'll look for a work night. If you're not already a GGDA member, go ahead and join at ggda.org. And thank you, Alex. That was a lot of fun.
Thank you for hosting me, as always.
Absolutely. All right, everybody. Have a great Monday. Stay warm and dry some way, somehow. And yeah, upcoming events. We mentioned Eric Lorenz, April 5th at the Supermarket Art Gallery. We expect the Best in Georgia, April 14th. And May will go crazy with Games Week Georgia, MomoCon, and DreamHack Atlanta. All right. Say goodnight, Alex.
Good night. Thank you.